Okay, Algebra 1 students, in this video today we're going to be learning how to solve linear systems by using the graphing method, okay? Now in the past we have learned how to check answers to see if they are a solution to a linear system. We have not yet learned how to, let me get my pen working here, we have not yet learned how to find the actual solution, and that's what we're going to do today, okay? We're going to do this by using the graphing method. So here's your heading. Please copy it down if you would, please. And also include today's date. Your heading is Solving Linear Systems by Graphing, Lesson 7.1, Part 2, and then of course today's date. Now it's very important that you put the words by graphing. It's very important that you do that because here's why. In this chapter we are going to learn 3 different ways to solve linear systems. 3. There's actually more than 3 methods for solving linear systems, but in this chapter we're only going to look at 3 methods. Before the year is over we will learn more than 3 methods, okay? So the method today is the graphing method, and you need to understand that, okay? Obviously in today's video we'll be learning how to use the graphing method as I just said. Now let me start off by giving a foundational statement about the graphing method. Here it is. Please write this down. This is the foundation for you to understand the graphing method. I'm not sure what I just did there, and still not sure what I did. Okay, there we go. Write this down, please. The solution to a linear system is, are you ready? It's so simple. Where the 2 lines intersect. That's it. Let me say that again. When I ask you to solve a linear system, you're simply finding where the 2 lines intersect. That's it. Please copy that down. Please copy this down. Anytime that I go too fast during the video, just pause the video. Now if you'll stop and think about that last comment that I just made right here, you can probably figure out how to solve linear systems by graphing without me even teaching you. I mean, seriously guys, think about it. If I'm telling you the answer to a linear system is where the 2 lines intersect, you guys do know how to graph linear equations, right? Sure you do. So let's say you graphed the 2 lines in a linear system, and let's say one line was hit this here, and the other line looked like this here. That's close enough. That's the best I can do. They intersect right here. Okay? Well guys, what ordered pair is that? It's over positive 3. And it's down negative 2. There, you did it. You just found the answer. So all that we're doing today, guys, is we're going to graph linear equations, see where they intersect, and that's our answer. Then of course we're going to check our answers too, because it's always smart and wise to check your answers. But do you not see how simple this is? Now, if you've not learned your math like you're supposed to, that's on you. Okay, I'm not being mean, but that's on you. But if you are still struggling with graphing linear equations, then you're going to have to get caught up, okay? But if you're okay with graphing linear equations, then you'll be fine, okay? Alright, so let's jump right into this material and see if we can solve some of these linear systems. We're going to look at 3 examples today. Take some great notes, pay close attention, and here we go. Copy that down, please, in your notes. Now, we are going to solve this system by graphing it. Alright, so let's take our first equation here. Let's bring it over here. You guys know by now Mr. Earhart likes to use the double intercept method whenever you have your x term, your y term, then your equal sign, and then your constant term. Is everybody listening? Listen carefully. If this constant term is a 0, then you cannot use the double intercept method. It will not work, because the intercept will be 0, and that means you have 1 point. That's not going to help you. Never use the double intercept method if this number right here is a 0, okay? But anyways, I love the double intercept method when I have x, then y, then equal sign, then a constant term. So here we go. Where where the x is, I'm going to substitute a 0. Remember how to do this? 2 times 0 is 0, 0 plus y is y, y equals 3. So there I just found my y-intercept. Boom. Now let's put 0 in for y. So 2x plus 0 equals 3. 2x plus 0 is just 2x. Divide both sides by 2, and 3 divided by 2 is 1.5. So students, we can now very quickly come over here. And remember, you've got to be pretty neat with your graph. Okay, you can't just be all sloppy, because if you're sloppy, you're not going to get out the right answer. Okay, so you don't have to be super neat, but try to be reasonable. Okay, as you can tell, I'm not being super neat, but I'm trying to be reasonable. I'm not just throwing up tick marks, in a sloppy manner. I'm trying to do this pretty neat. Graphing paper is great. If you have graphing paper, use it, but if you don't, you can still solve these, as you're going to see in just a second. Let's go ahead and graph this linear equation. The y-intercept is 3. The x-intercept is 1.5. And right here. And here we go. We'll try to sketch this line the best that we can. I think I will use my shape recognition here to help me out a little bit. And that's pretty good, not too bad. Slide over just a bit, and that'll have to do. Okay, so there we go. So there's my line. X-intercept 1.5, y-intercept 3. Now let's take our next equation, and let's graph that equation. Okay, and we'll do that with a different color of ink. We'll go with green. So notice I have my x term first, then my y term, then my equal sign, then a constant term that is not 0. So I'm going to use the double intercept method. So where the x is, I'm going to substitute a 0. Negative 0 is 0, 0 plus y is y, y equals negative 3. So there's my y-intercept. Now where the y is, I'm going to put a 0. So negative x plus 0 equals negative 3. Negative x plus 0 is negative x. If negative x equals negative 3, then change both the signs. X equals 3. So my y-intercept is negative 3. 1, 2, 3. And my x-intercept is positive 3. Right here. Alright. Now I'm going to go ahead and do the best I can to sketch that line. My line's not going to be perfect, but actually I've got a lot of work to do, don't I? It's not very good, but anyways, that's going to have to see if I can do that a little better. Alright, there we go. And there we go. So I graphed the two lines. Do you understand, students, that so far in this video I have taught you nothing new? We learned how to graph linear equations a long time ago. So they both intersect right here. Now, it's not perfect, but it looks like it lines up with positive 2 on the x-axis and negative 1 on the y-axis. So I'm assuming that's my answer. Okay, now I could be wrong. Well, Mr. Earhart, how can it be wrong? You graphed it. Well, guys, graphs aren't perfect. Look how close these two tick marks are. Then look how far apart these two are. Look how not perfectly straight my green line is. Look how far apart these two tick marks are, and these are a little closer. So it's not going to be perfect. And by the way, are you listening, guys? Listen to me. Sometimes an answer can look like this. 0.3, comma, 0.89. You never want to solve a linear system like that for graphing. That would be so hard to see 0.3 and 0.89 because, 0.89 could be 0.9, 0.3 could be 0.31. So graphing is a good method to use, but it's not the best method to use, okay? And also, when the answers aren't whole numbers, then it's going to cause problems. But for now, we're learning the graphing method. It's fine. So I'm assuming this is my answer. Now on your homework, you're going to find an answer like I did. Then you're going to check it to make sure it's right. So let's check this answer and see if we're right, okay? Remember, we learned how to do correct. I taught you guys how to check an answer yesterday. So let's check it, okay? Let's take my first equation here and let's see if it works. Where the x is, I will put a 2. Where the y is, I will put a -1. Let's see what happens. 2 times 2 is 4. Positive -1 is -1. 4 minus 1 is 3. So far, so good. Let's check it over here. Negative, parentheses 2, positive, and then -1. Looks pretty good to me. Negative, positive is -2. Positive, negative is -1. A -2 and a -3. -1 is a -3. So it checks. So this is my answer. Got it? Okay, moving on. Let's try another one now. If you think you got the hang of this, you can work ahead, but I am going to throw in some different methods of graphing because I don't want to use double intercept every time. I want us to, how did I do this? Somehow I scooted this thing up, and I don't want to do that. Well, I'm not sure. Anyways, we'll bring this down for now. That'll work for now. So there we go. Okay, now look, guys, we're gonna try another one. Feel free to work ahead. Just make sure you keep your eyes up here and watch. Okay, I'm going to use a different method. I'm gonna graph. We're gonna solve this. Okay, you understand that? So if we're gonna solve it, we've got to graph this line here, or get this equation here, and then this equation here, and see where they what? Remember? See where they intersect. All right. So with that in mind, I'm gonna start with my top equation here. However, yes, it's true. I do have my x first, then my y, then my equal sign, then my constant term. My constant term is not a 2. So the best method to use here is the double intercept method. However, just so for the sake of reviewing, I'm going to use the slope intercept method. It's good for us to review these methods, guys. I'm telling you, you need to know all of the 3 methods we learned for graphing linear equations. Do you remember the 3 methods? The double intercept method, the slope intercept method, and the table of values method. Okay, you need to remember that. So I'm going to use the slope intercept method to graph this linear equation right here. Okay, so here we go. First of all, to use the slope intercept method, get y by itself. So bring the positive x over, make it a negative x. So y equals -2 negative x. Now, is y all by itself? Yes, it is. If there would have been like a 3 here, pretend there's a 3 there, then you would divide everything by 3. There'd be a 1 here, so 1/3 x. Okay, but there's not a number with the y, so we're good. Is the y isolated? Yes, it is. So now I write out my m and my b. M is my slope. The slope is always the number in front of the x, even though you can't see it, it's a -1. So my slope is -1. B is the constant term. My constant term is -2. So that's my y-intercept. M is your slope. B is your y-intercept. Okay, let's slide it over here. Let's draw our coordinate plane here quickly. And here we go. And again, no one's looking for perfection, but try to be as neat as possible. Now, my y-intercept is -2. That's my b. So I go to -2, and I'm going to put a point right there. Now, from that point, I'm going to rise, and I'm going to run. Your slope is -1. Now, remember, we really want that to be a fraction. So we're going to put it over 1 so that we have a fraction. Okay? So my rise is my top number. Remember, it's rise over run. So I'm going to rise a -1, so I go down 1, and then I run a +1 to the right, so down 1, then over 1, and there's my other point. If you wanted to, you could have put your negative sign in the bottom, and it will still work. You have a positive rise, so you go up 1, and a negative run, so you go to the left. Either way, you'll have a point here, or you'll have a point here, and it doesn't matter, it's still the same line, okay? They still line up in the same line. So it's going to have to do. Alright, so there we go. So there's my line. Now, let's graph the other linear equation. Now, I'm not going to use the slope intercept on this one. It's longer and there's no need to do that. I just wanted to do a different method just to review, okay? We'll do this one in blue. So where the x is, I'm going to substitute a 0. I'm going to use the double intercept method. 2 times 0, 0, 0 minus 3y is negative 3y. Divide both sides by a negative y, or negative 3, and y equals 3. So there's my y-intercept. Now, I'm going to put a 0 in for y. Only I forgot to. There we go. 3 times 0 is 0. 2x minus 0 is 2x. So 2x equals negative 9. Divide both sides by 2, and x equals a negative 4.5. Alright, so 1, 2, 3, 4.5. So approximately right there. Alright. Now, let's go ahead and connect our 2 points here. And I think we'll be hopefully getting out the right answer. There we go. Now, they intersect right here. That's really close to negative 3, positive 1. Negative 3, positive 1. So, and by the way, are you listening? On a test or a quiz, when I have you use the graphing method, are you listening, guys? I will always make sure your answers are whole numbers. I'm never going to give you a graphing method problem and have the answer be decimals or fractions, okay? So negative 3, positive 1. I think that's the answer. Okay, I'm going to write it up here. And you know now what we have to do, right? We have to check our answer. So here we go. Let's check it and see if we did this correctly. Alright, here we go. Alright, now, we'll start with this equation first. Where the x is, I will put a negative 3. And then where the y is, I will put a positive 1. 2 times negative 3, negative 6. 3 times negative 1, negative 3. Negative 6, negative 3 does equal negative 9. So we're good there. Let's check it in the other equation real quick here. Where the x is, I want to substitute negative 3. Where the y is, I will substitute 1. Negative 3, positive 1 does equal a negative 2. So it checks and it checks. Okay, guys, so what we're learning today is to graph two equations within the linear system, see where they intersect, and that will be our answer. It's called the graphing method, okay, for solving linear systems. Alright, last one, and we are finally finished, so here we go. Okay, let's start off with this equation here. We have two linear equations, so obviously we're going to have to graph these real quick. And by the way, I did not want this negative 16 to be there. Let's change that real quick to something else, please. I did not want to have to put 16 tick marks. I saw that earlier, and I just forgot to change it, so hold on 1 second, please. Let's say, let's see here. Let's see here. Let's say y equals 4. That'll give us out a good whole number. Okay. All right. So here's my two equations. 1, 2. Well, Mr. Arrow, this equation here doesn't have an x, so it's still a linear equation. Your variable, or excuse me, your exponent's a 1. That's a linear equation. Okay. And we know how to graph these. If you have just a y, it's a horizontal line. If you have just an x, it's a vertical line. So we know how to graph single variable linear equations. Let's start off first with the more difficult one, okay? Let's graph this. Now we have yet to use the table of values method, so I'm going to use the table of values method. Now, technically, the best method to use here is the double intercept method, because you have x, then y, then an equal sign, then a constant term. That's not a 0, okay? But for the sake of review, I'm going to use the table of values method. So I'm going to choose these numbers here. I'm going to put in -1, 0, and 1. Those are my three numbers. You can pick any numbers you want to. Okay, that's up to you. I'm going to put a -1 in for x. And then solve for y. 5 times -1 is -5. Bring the -5 over and make it positive. That would give you 21. Divide both sides by 4 and you will get, let's see, 5 1/4, so 5.25. Okay? Alright, moving on to substituting 0 in for x. 5 times 0 plus 4y equals 16. 5 times 0, 0, 0 plus 4y is 4y. Divide both sides by 4 and y equals 4. And lastly, let's substitute 1 in for x. So I'm going to put a 1 in for x. This is the table of values method. Hopefully you guys are remembering this as I do it. 5 times 1 is 5. Bring the 5 over and make it a -5. That would give you 11. So 4y equals 11. Divide both sides by 4 and you will get 2 and 3/4, so 2.75. So there's all the information I need to graph this linear equation. Let's slide it right over here so we can move this whole thing over. And let's graph our line. Here we go. I don't think that's any better, but that'll have to do. Alright, let's go ahead and plot these order pairs. -1, 5.25, 1, 2, 3, 4, 5 1/4, so about right there. And then 0, 4, so 0, 4. And then over 1 up 2.75, so about right there. They line up pretty well within a straight line, so I think we're doing okay there. There we go. Okay, so we have graphed this linear equation here. Now, let's graph this linear equation. Y equals 4. That simply means we're going to put a point on the y-axis at 4. And we're going to draw a horizontal line. And there it is. So they obviously intersect right there. So we're done. That's it. Guys, it's not difficult. So this order pair right here is 0, 4, right? 0, 4. So that's my answer that I'm claiming is correct. Let's check it and see, okay? Here we go. Let's check and see if this answer is correct. Alright, here we go. Let's take our first equation. We're going to put in 0, 4. So where the x is, I will put a 0. And where the y is, I will put a 4. 5 times 0, 0. 4 times 4 is 16. 0 plus 16 is 16. 16 equals 16. Check. Now let's check our answer in the other equation. Now, remember I changed this to y equals 4. Alright. So you're saying, Mr. Earhart, there's nowhere to put in the 0. Don't use the 0. Don't worry about it. There's no x, so don't put in an x. There is a y. So substitute your y in. For y, I'm going to put a 4. And I get what? 4 equals 4. Check. We're good. That's it, guys. Look, students, this material is not difficult. It's actually quite simple, as long as you remember the foundational statement I gave you at the beginning of the video. The solution to a linear system is where the two lines intersect. If you know how to graph, I'm using a mouse now, so my handwriting's going to be a little messy here, but if you know how to graph linear equations, then this material should be a piece of cake for you. If you don't, then you have to go back and learn that and make sure you're caught up, okay? I hope this video's been a help to you. If you have any questions at all, don't hesitate to call or email.